Hello there. Let's talk about stack alignment. When you're linking and running a program for x86-64 using a Yasm assembler, and also you have a hybrid program, so you're using the GCC libraries in order to get some extra functions or extra functionality, or just so you can have different types of source code in your program. Okay, so this video is not about how to make a hybrid program. Look for my other video for that topic. This video is only about solving a common problem which costs people tons of time, called stack alignment. Imagine this: you're writing a program, a hybrid program, and every once in a while you call on a function within the GCC libraries, or perhaps you call another function that you don't control, or something that might in turn call on a GCC library, and you can't figure out why, but your program keeps crashing. For no reason, seemingly. You've spent hours and hours debugging your program. It appears to be correct, but it still crashes. If that happens to you, there's a chance that you're suffering from stack alignment issues. So what do I mean by this? I mean, basically, the GCC libraries, they expect that your stack, which is the data structure you use when you're calling a function or returning from a function, or you're making local variables, or you're like pushing, when you're pushing and popping stuff onto the stack, GCC expects that the stack is aligned to 8 bytes. So that means basically every time you do a push or a pop, the stack kind of goes out of alignment and goes into alignment. So like I do a push, the stack goes out of alignment. I do another push, the stack goes into alignment. I pop later, it gets out of alignment. I pop again, it goes into alignment. Every time you do a function call, every time you modify the stack by a certain number of bytes, it could potentially be going out of alignment. I think it stays into the same alignment if you push twice, as far as I recall, or if you jump quickly twice. But the point is, this is kind of a precarious thing, and maybe sometimes you're not sure, am I suffering from stack alignment? Well, here's how to check and make sure that it's not happening. So first up, I just want to show you my Makefile real fast. This is not a Makefile video, so I'm going to very quickly go through it. This is a hybrid program, so I just have some variables at the top for C++ compilation, and some variables over here for assembly in Yasm. And then I'm going to link using G++. Anytime you're linking with G++, that means the G++ libraries are there. You should already think to yourself, maybe it's at least possible stack alignment could be some of my crashes, especially if you're actually calling GCC libraries, or a library that you don't control, or a library that you don't know what the source is inside of it. So I'm just, I have a little menu here, and then there's like a run target, and then all I'm doing is I'm just compiling a driver and an assembly module called whoops, which will do the stack alignment issues for us, or which will show us the issues. The driver is pretty simple. It's the entry point for the program. It's got a main function. It just prints a message, and then it calls our whoops function just to prove to you we're in a hybrid program. We've got an extern C block to disable name mangling on the whoops program so that the C++ module can call on the assembly module. That's not what this video is about. Check my other videos if you're interested in more of that, or if you're still trying to figure out what to do. But basically in the assembly module, I define some stuff so that I can print string messages. This is all covered in other videos that I've made, but we're just going to say there's going to be a welcome message, and then I'm going to actually call on a GCC library, a regular like C standard library, printf, to just kind of print something for us. Then we're going to do a goodbye message, and then we sort of enter up here. So the first thing you probably are wondering is, wait a minute, can you call printf from assembly? Yeah, you can if you're linking with the GCC libraries. There are a lot of functions out there that provide extra functionality. Just be very careful that you don't accidentally, like if you're doing homework at home, be careful you don't accidentally get in trouble for using a function that was pre-written in order to accomplish something in your homework that you were supposed to do. So be careful about that. You could, depending on your professor, you could lose a lot of points, or all the points, or whatever. So anyway, you can call printf and other C and C++ library functions. All you have to do is, number one, make a hybrid program that links against the GCC libraries, and number two, name the functions with extern. So I want to call printf in this program. So I'm just going to say extern printf to indicate to the linker that this whoops module should be able to see the printf symbol, which it should link to it because it's like in another module somewhere. It'll be inside the GCC library. Then the entry point for this particular module is just a function that I expose as global so that other places in the program can call on it. And I'm just calling it whoops. I am, let's see, writing this as a function, not a regular assembly label that has to be syscall exited. So that means this is a function where I have to actually return when I'm finished. This is not a functions video, but again, if I was using any callee preserved registers per the ABI, then I would do like a push pop pair on the top and the bottom, but I'm not. So first thing that happens is we just print a welcome message. No problem. This is not a printing tutorial video, so check out my other videos. And then we'll actually just call on printf. We'll ask printf, could you print this string for us? And then we'll say goodbye with just another print. So this is the problem here, the call to printf. It seems good. I mean, all we're doing is we are respecting the ABI by saying, all right, printf wants a pointer to the C string that we wish to print. And so I'm just going to load up the first integer argument, which also could be a pointer argument, RDI, with a pointer to my string, just printf message, and then I'm going to call printf. Should work. Let me show you what is actually in the string, just for your information. The string is just a message in quotes that says, this is a string printed by printf. And then I add a carriage return line feed to the end of it. So printf will do the new lining all for me without me having to call another function. And then I give it a null terminator. I'm not going to explain null terminators too much in this video, but just keep in mind, this kind of thing is required for printf because printf will scan. Printf doesn't actually need the length of the message, so I don't even know why I put this in here. So line 24, totally useless. Anyway, so this feels like it should work, but it's not going to work. Let's see what happens. If I do, well, I'll do clear and make run, then you can see that the program gets compiled, and then we get the welcome message from the driver. It says, my name is Niles Peppertrout. That's not my real name. I just love those names. And then it says, I will now call the whoops module. That's the driver talking. And then now we're inside of the whoops module, and it says, hello, this is the whoops module. And then we get a segfault. Program crashes, your program doesn't work for your customers, or you don't get your points on your homework or whatever it is, because we have a segmentation fault. This is not good. And this happens to lots of people. They're coding and they're debugging for hours and hours and hours, not understanding where the segfault is coming from. It might be coming from stack alignment. In this case, I know for sure it's coming from stack alignment just because I wrote the program on purpose to crash. So let's look at a way to, first, to debug this, your first clue is, I am sure that it's working, it's still crashing, and I'm calling something that is GCC, or I'm calling something that I don't know what the code is inside. It could be calling GCC, like if you have a library from somewhere else, maybe it's calling GCC, you don't really know. So that's my first clue. I'll go into the source code and I'll just kind of try something. So at the beginning of my function, we know that every time you jump into a function or do a function call, then the stack changes a little bit because the stack has to store the return address of where you're going to return to later. So that means there's a potential here for stack alignment issues. And I'm going to go ahead and try something to see if I can prove to myself that this is a stack alignment issue. What I'm going to do is I'm just going to move the stack by 8 bytes. So how do we do that? You could either move the stack pointer forward and back if you wanted to, like we have add or subtract. I think subtract would be what we want to do just to the, let's see, where is it? RSP, the stack register. I'm not going to do that here. I'm just going to prove a point and make things a little bit easier. We'll push the number, or sorry, we won't push a number. We'll push RAX, and then after that, we'll pop RAX. And what's happening is I'm changing the alignment of the stack, and then I'm calling on printf, and then I'm changing the alignment of the stack again. I'm sort of like, you can imagine I'm just like pushing a dummy value onto the stack. Like we don't really care what's inside of RAX. We're not trying to preserve RAX. We're not going to use the stack or anything like that. So I'm just saying, well, let's just put something on there. I don't even care what it is. And then when we're done, we'll just pop it right back off. That way, when we're finished, the stack is really unchanged, but inside of that push pop pair, the stack is differently aligned by about 8 bytes because, well, this right here is an 8-byte register, a 64-bit register. So we're moving the stack, then we're doing the call, and then we're moving the stack back. Run with only that one change. You don't want to make the mistake of making a bunch of changes because then it's hard to figure out which change actually worked. With just that one change, I'm going to run the program again. Notice how the program finishes correctly. So, of course, nothing in life is 100%, but at this point, I would be pretty sure that my issue was stack alignment. I don't know where the stack alignment came from. Maybe it came from the function call. Maybe it came from some push pops I had at the top or the bottom. I don't really know. You can probably bet that if you call on another function that respects the ABI, that when your function comes, when your call comes back, the stack's not going to be in a different alignment, which means, let's say I had like many calls to printf here. I wouldn't necessarily want to like move the stack back and forth every single time I called on a function. I probably would want to put this push pop pair like at the very top in the prologue, maybe. Let's say prologue. I'll do like just push RAX and then leave myself a comment because it's easy to forget assembly in assembly, like what you're doing. So I'm just going to leave myself a note and I'm just going to say stack alignment just to remind myself not to accidentally remove it later. And then I'm going to do a pop RAX at the end. So I'm going to do like an epilogue. Epilogue. I thought I spelled that right. Epilogue. I am sure that I'm spelling it right. Okay. So then I'm going to pop RAX. And hilariously, since you don't really care about the value of RAX, you could pop a different register as long as it wasn't callee saved. But just so this is a little bit easier to understand and more stable, I'm going to do it this way. So then I'm going to say stack alignment. And maybe I want to like line up these comments. So I'll just kind of like line up the comments. So now the whole entire function, because if you look inside of the body of my function, I'm not really changing the stack alignment. I'm not modifying the stack register. I'm not doing any more push pop pairs. I'm not doing anything. So probably the stack is out of alignment during the entire function, which means I can make my function a little bit faster now by removing these push pop pairs that are surround the printf calls. So, I have like half the number of push pop pairs at this point. So let's see if that works. Notice how the program still runs. No problem. And just as another experiment, I'm going to comment out the push and the pop pair. You got to comment out the pair, not just one push and not the pop or vice versa. Otherwise, the whole program's not going to work. So if I commented it out, now it should crash for sure. Notice how it crashes. All right, so if I put it back, one more experiment just to be, like really obsessed with the specificity and make sure that the program works, just to be really robust, and it works. Okay, so this is stack alignment in x86-64 GCC library dependent hybrid programs in Yasm. I'm sure this applies to a lot of other areas, but Yasm x86-64 on Linux is what I'm doing, so. I hope this was helpful to you. I hope you learned a little bit and had a little bit of fun. I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. and it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness, which is coming for us all.